Hello and welcome to my YouTube channel. I wish you a very warm welcome. And in this video, I'm going to talk to you about the Kaufman efficiency ratio. Now, this is a very interesting indicator, and it was devised by Perry Kaufman. And I'm a fan of Perry Kaufman. I remember reading his books back all the way from my CMT days and even after that. Right? So if you're an algorithmic trader, or even for that matter, a discretionary trader, a quantitative trader, you can call yourself anything. The main thing is that this indicator is of much use to you. If I was to tell you in simple language what is meant by the efficiency ratio, let us understand this. We all hate trading sideways markets, especially when we're trying to find out the trend or the direction, right? And we love trading smooth markets, flowing markets, trending markets, where you see continuous green candles or continuous red candles, right? So the efficiency ratio helps us to separate those times where the market has been moving very efficiently or very smoothly, and those times when the market is actually discovering the price or sideways and it's choppy and it's not really moving in one single direction. So this is how the efficiency ratio helps us. And in order to illustrate that, I'm going to show you how exactly we can do various things with it, right? So here I'm going to share my screen, and today we're going to learn about it more and more. Then we're going to eventually code it also. Okay. So this is how the efficiency ratio looks like. It looks like it's oscillating between 0 and 1. And you can see that during the trending times, you will see the efficiency ratio go higher, right? Now, I just pulled out some resources which are public, and you could learn a little more about efficiency ratio in that sense if you could go here. So there are ways to code efficiency ratio, and say the Quant Connect shows a little picture. This visualization is, I feel, something very clear. It shows that okay, I think this must be done on Plotly, but this clearly shows how the efficiency ratio is looking like in this case. And also, I found this website which had a very clear idea about the efficiency ratio in terms of, you know, what all are the calculations behind it. And I think we will just dive deep into the calculation behind it, which I found was pretty authentic and pretty the way I like it, where I like to see the indicator. I remember reading Terry Kaufman's book, and in that book, he clearly mentions that students of the market, traders, analysts, all of us, when we are using a technical analysis based indicator, we should definitely know what the calculation is behind it, not just how it visually looks. So if we know the calculation which is behind it, it gives us a very strong intuition and idea about how we can use it in various ways. Now, previous to this, I have shared about the RSI divergence. I've even shared about the super trend. I've showed you how you can put both of them. Right, there are videos on my YouTube channel you can see, and I'll put all of this in a similar playlist. But this one is not very complicated to code. It is not very complicated to, perceive. So the calculation is very simple in that sense. But yes, we're going to use some coding brain and we're trying to code it, and you're going to enjoy the entire process. So how I'm going to go ahead is first I'm going to show. I showed you the efficiency ratio, how it looks like on Quant Connect. I'm also going to show it to you on Trading View. So say for example. One second. This is the Nifty chart. I have just made it a 5-minute chart. So you can see the efficiency ratio again oscillating between two levels, right? So I think this is a pretty clear picture. And you can see the efficiency ratio has the number 5 next to it. So the parameter which is mostly used, or the default parameter or the recommended parameter also in some case, you can say, is 5, right? Now, if I convert this to the daily chart, again, it is going to show you. Oops, let me just hide these, yeah, just so that the chart is clear and neat. You can see that whenever the market is neatly trending, during those times, we can see, just a second, let me just draw it pen. So during those times, you see that the efficiency ratio is moving from 0 to 1. And when the market is sideways or choppy, or it's not finding some sort of direction, then you can say that the efficiency ratio is very close to 0, right? So how you want to use it is up to you. and how you can play around with indicators and parameterization to a very great extent when you're doing quantitative research, when you're trying to make algorithmic trading strategies, right? And for that matter, I'm a fan of this indicator. I'm not saying I use it directly. I use it in every strategy of mine. But yes, I have found it very useful in the overall scheme of things in my research, right? So I would like to share more about it. Now that we are clear about what the efficiency ratio does, let's have a quick example of how we can code it, right? Now, as I said, it is always, many times it is always good to actually have the code directly from a library, but sometimes it is equally important to actually understand what's going behind it. Try to code it ourselves. Right? So, the people who use libraries which are more popular, they tend to don't have efficiency ratio. Just like Super Trend was missing, and then we explored with Pandas. See in another video, you can see it on my channel. So herein I'm importing the important libraries, and then I'm doing my thing with my matplotlib. So just my charts are much more beautiful and aesthetic to look at, right? And now we come to preparing data, a quick function, in which I'm using the Y finance library. Now, for those who are very new and need some basic idea, so I have imported Y finance is YF. This is to be able to pull the data, right? Download data directly from the internet. Herein, more very important is pandas as PD, NumPy as NP, data as DT, right? And matplotlib as .python as PP, right? And herein, so what I'm creating is a function which will help me prepare the data. I'm keeping things very, very simple. I'm just taking Nifty data, right? And we're going back in say 10, 12 years, even if we go for lesser, that's also fine. But here we're going about 10, 11 years back, 10.5 years back. And the end is equal to dt.endtime.now. So since I already imported the datetime library over here I'm using dt.datetime.now to tell my machine that yes, tell the program that yes, this is the end time what I want. So I want all the data starting from here up till now, right? And then finally, what happens is I put all of that in data frame called data. I say this is yf.download, right? Uh, so what basically it does is that now I think I missed something over here, and I think this is something I tried but a week back. So I think there is. I'm just going to run df is equal to prepare data, right? And this is running and this is already running, it's not giving me anything. So I need to stop this. I need to just make small correction, which I have missed out. Uh, so, okay, here we go. Now, this is NACI, right? And start and hit. Right. Now we will get all our data. Once we run df is equal to prepare data, we should be getting all the data. And I think I have not run any of this. I just opened this. Never mind. So here we go. Df is equal to prepare data. We have got the Nifty, right? Now let's just do df.head quickly. Df.head is going to show me that everyday daily data of Nifty is available starting from the starting data as I had mentioned. And this data frame of ours is ready, right? Over here, I have also written another function which I'd like to make a very clear focus on and explain step by step, right? So here we have got a data frame which we have in which we have the close column, right? So just follow whatever I'm drawing over here. So we have the close column, right? And in which we have the closing prices for each and every day. Now, if you notice this over here within this function, first of all, I'm making a copy of the data, right? Just so that I don't disturb the original data set. And here with the copy of the data, I'm creating a new column for price change. Simply taking the difference between the closed prices. Please note, this is not dot percentage change or dot PCT. This is dot diff, right? So it is going to simply take the difference between. So if I have the close price, obviously I have the date and the open and the high and the low, etc. But here my focus is the fixed, right? So I have got a number of columns, but my focus is so close. And I've created a new column called, what did I call it? I called it price change. Price underscore change, right? Now, in this column, what I'm going to get is I'm going to get the difference between the two closing prices. Now, if you notice over here, the first closing pricing has nothing to get a difference from. So I'm eventually going to get an NEN value. And from the next on, I'm going to get the difference between whatever there is, and it is going to populate this particular column with the differences, right? So now that I know that in my data frame, I have a NA value, that is not something which I like because I need to work around with this data, right? So I put a df dot drop NA in place equal to true. Now, as I said, I'll be referring to this website, just to make it very interesting for you that how it is actually coded, right? So when it comes to the efficiency ratio, we simply have, just a second, yep, right. So we take something, we take efficiency ratio is equal to change divided by sum of absolute changes. Now, this change, as I'm taking the 5 efficiency ratio, 5-day Kaufman efficiency ratio, uh, I'm taking the absolute 5-day change, and I'm also taking the sum of the absolute changes over the 5 days. I'll get into the logic in a minute as to why I am doing it, right? So, the logic over here is very simple. That first, let me just take it as it is given in the formula. So let's take the 5-day change, right? So the 5-day change is very simple. In the data frame itself, what I will do is I create a fresh column for 5-day change, right? And while I'm creating the 5-day change, I'm going to use the dot diff again, and this time I'm going to pass periods is equal to 5. So a five periods are passed, right? So let's say, for example, over here, just like I had the price change, I have the 5-day price change also, right? And in this 5-day price change, after the first, so it is going to compare from the first to the second, third, fourth, fifth, and my data is going to get populated from here. I'm going to get the 5-day price changes, right? And so on and so on. So that is how it will happen. Now, I need the 5-day price change. So every data point here is actually representing a 5-day price change, not just a 1-day price change, right? That is going to be a part of my numerator. Now let's understand this. We have now created a fresh column called change underscore ABS. That means I want the absolute value of the change. I just don't want the change itself because the change can be positive, the change can be negative. And in my formula, what I'm using is the absolute value of the change, right? So herein, what I'm going to simply do is I'm going to create a fresh column, and the function itself will create a fresh column, which will be the ABS price change, right? So it is going to create an absolute value of all the things which you see over here, and I have done that absolutely easily, like pretty directly over here by putting the ABS outside and passing the entire data frame price change. So the vectorization format, I'm taking not the data frame, the entire row, so entire column. The entire column price change, I have put it in the absolute function and I'm pulling out all the absolute values, right? So why is the absolute price change so important? And later, why is it useful? So let me just rub my board and show it to you again. So let's say, for example, if a price is trending pretty choppily, right? Sometimes it will go up, which will create a positive pricing. Sometimes it will go down. It will create a negative pricing. It will create go up again, positive, negative, positive, negative. And each one of this will have some values. So suppose I was to take only the absolute value, even if it is a -2, I'm taking 2. If it's a +3, I'm taking 3. If it's a -1, I'm taking 1. So what I'm doing is I'm actually taking all the convolutions, right? All the convolutions, which originally may be a negative change or a positive change, but I'm taking them as a positive change. I'm taking the absolute values so that I can understand that these are the total of the price fluctuations. Now, if the market is sideways, the total of the price fluctuations is more because of the sideways movement. When I say fluctuations, I mean both up and down, right? So the sum of it, the sum of day 1, 2, 3, 4, 5, because I'm using the parameter 5, I'm going to take the absolute values of those, right? And let's imagine, and also I'm going to take the 5-day change. So let me just do it with another color for clarity's sake. So suppose the 5 days go from here till here, and the 5-day change is only, say, for example, 3, right? And the first 5 days changes 2 plus 3 plus 1 plus 0 plus 3, right? So if we notice that these are the absolute value of the changes, and this is the single change of 5 day alone. Like if I jump from day 1 to day 5, this is the single change alone. And in case it was -3, I would still take the absolute value because our formula takes the absolute value. So basically, the absolute value of this 5-day change, right? 5-day change, jumping from 0 to 5, the 0th day to the 5th day, uh, and then taking individually day 1, absolute, 3, 4, and 5. This is the job I'm doing. So now imagine I'm saying that the ratio is moving, largely speaking, the ratio is moving between 0 and 1. And if this number, the absolute value, why it will be 0 and 1? Because obviously uh, you know, we are taking the absolute values, right? So it's not going to be a negative number. It's going to be a positive. So between 0 and 1. So if the absolute value, so in case there was not sideways movement, let's take another example where there's a trending. In case there's a trending movement in the market, so every change would have been significant in 5 days, but there would not be too many convolutions. Or if there would be, and the whole change, suppose, would be 100, right? The individual changes would be plus 20, plus 30. If there was a -10, I would take it as a plus 10, plus 40, and so on and so forth, right? So what I'm trying to say is that if the absolute change is small, that means the numerator is small in 5 days, and the total convolution is big, right? We are going to get the ratio value very close to 0, right? Because we have got a smaller number in the numerator and a bigger number in the denominator. I hope I am clear, right? So in here, you will see when the market is sideways, the efficiency ratio moves around this. And when there's a trending market, you see the efficiency ratio move towards 1. So this is the logic behind efficiency ratio. Now let's get back to our code. And here is what I have, I have made a simple calculation. I've done again a df.drop in it because, I'm taking the absolute values, I'm taking the price changes, I'm taking a 5-day jump. So I'm trying to pull out and scratch out the NEN values from my number, right? From my data frame. Now, the final efficiency ratio column is created. This creation of the efficiency ratio column is simply the absolute value of the 5-day change divided by the sum of these 5 days change. Now, how did I come to the sum of this 5-day change? This is something which I have to explain to you. Now, as I said, I have already calculated the absolute value in a certain column of all the price differences. So, coming back to the board, I have calculated the absolute value of all the price differences, right? And there is a column populated with numbers, right? Now, oops. Now, all I need is I need to actually, where is my mouse? Yeah. So all I need is I need to create a rolling sum, right? A rolling sum will do what? It is going to take 5 days, 1, 2, 3, 4, 5, create a total and create the summation of it. Then it will leave out the first and take the next 5 days and create a summation of it and give me a fresh column, which will actually be, sorry, which will actually be the 5-day change sum. So all I need to take is the 5-day jump from 0 to 5, right? And then I want to take from the 5 days altogether individual total, which is the summation I have created over here. And then I return the data frame with all these columns and populate it. Now let me run this over here, DF efficiency ratio. Okay. DF is equal to efficiency ratio, and I pass the data frame. So you see the data frame which I have to pass. Now, if you notice over here, I have created periods is equal to 5. Suppose I don't put anything in this function. Those who are not familiar with the basic of functions in Python, suppose I have already created periods as an argument and initiated it to 5. I've assigned 5 to it. That means it is not compulsory for me to pass this argument. I can very well let go of this argument, and whatever calculation is done is on the basis of 5. And herein is the period where I have taken the rolling sum of 5 days, right? Suppose now you wanted to change this, you will have to modify the code a little more, because here is also a period. So I've taken a 5-day change and I've taken a 5-day rolling sum. So all you need to do if you want to modify the code to check out for the 10-day period, you need to just add a comma while you are and add 10 over here, right? I'm not doing that, but you can. Going forward, now let's check out df.head. Now, if you notice over here, we've got all these columns populated. First, I've got the price change, which is not the absolute price change, right? I've also got the absolute price change. So you see minus 54 over here has become plus 54, right? Also, I have got, so this is the absolute price change. You can see very clearly. I've got the 5-day change. So the difference over 5, which is very different. And I've got the 5-day sum. So this is the sum of 5 days absolute changes. So if I'm going to divide the 5-day change, right, by the sum of 5-day changes, I'm going to get a number like this, which is the efficiency ratio. Over here, you can see the efficiency ratio is moving from 0 towards 0.5, from moving from 0.26 towards 0.5, right? Now I'm going to plot this now that I have it in my data frame. And so what I'm going to do is I'm going to plot this. Here I have created T is equal to df.copy. So I'm now calling my data frame not df but nifty, right? And I'm going to not get too much into the technicals of this, because you can always go back and check it out on YouTube, pause the video, code it yourself, right? To create the subplots. So you have to be having some grip with the matplotlib, right? Now moving on. So here, if you notice that I have created this for the minus 200 colon 0. So the minus 200 colon the last index, it is showing me only those values. That is why it is a very smooth looking graph. Otherwise, so many years of data would be a very choppy looking and noisy looking graph, right? So if you want to explore something else, say for example, you want to change this to maybe 100 instead of 200. It will help us to look at only the last 100 days data, because we have taken the daily chart, right? You're most welcome to experiment with the smaller time frames, which I would love that you do. And now I'm going to run this again, and you see this is only the last 100 days, right? So you can see that the market is pretty smooth in certain junctures. And those junctures, when the market is so smooth, those market regimes, the efficiency ratio is also pretty much showing us that there is a increment which is pretty slow, right? Now again over here you see the efficiency ratio also pretty smoothly goes up with it. And obviously, like many other indicators, there would be a little bit of lag, but it has as minimum lag as possible. The little bit of lag will be that if you take a higher number, greater than 5, the lag will increase, right? So those kind of things are there with any kind of price indicator. But this is how you can use efficiency ratio. And now that you have an efficiency ratio column on your data frame, for those who love to do algorithmic trading and find out more interesting strategies, you guys can actually figure out where to go and what to do with the data frame. Now, if you're completely new to algorithmic trading, please do check out www.com. Go to the courses section, right? In the courses section, you will definitely get what you're looking for. and that is the Algorithmic Trading Course. And I have got some other courses also on markets and trading, right? And then there is the digital product section. In our digital product section, I'm going to give this particular Jupyter notebook, the Collab notebook link for free. So what you need to do is you need to go and buy it for free. Right now you can't see it. Right after the video, I'm going to put it up, right? You can also see that the other free resources which I have shared. So all the best to you all. And also, since we are at it, you could also check out my YouTube channel. My YouTube channel has got a lot of videos. You are on my YouTube channel already. But you'll see a lot of interesting videos on trading, Python, the usage of coding and programming in quantitative finance, and this will help you become a more interested, curious, fulfill your curiosity, and become a better trader. Right? So you can check out a lot of the resources also. So thank you so much, ladies and gentlemen. Take care, goodbye, and enjoy.